introduction. For those of you that don't know, I'm Dr. Blauck. I'm an adjunct professor here, and I think this is my 9th year I've been adjunct here, which seems like a really long time. It is. Just to tell you briefly about the students here in the project, and I'll let them get into the details. Great. All right, now we make these pictures. Yeah. You guys can stand in the back of this. All right, so I've taught a couple Capstone classes here, and ECPI students definitely are not afraid to pick challenging projects. And so 5 weeks ago when they told me their idea that they had, I thought, no way. I didn't say that to them. All right, we'll see what happens. And they were excited about it. I think it was Nick and Chris's idea, and they talked you guys into it. But after the first week, I knew they were going to have something working. It was going to be a good project for them. And they worked really well together and accomplished a lot of stuff. And I saw a lot of really good engineering, designing, troubleshooting in the process. So without further ado, I'm going to let them take over and show you what they've done.
Great. Before we start, I just want to thank all of y'all for coming out to see this. It's awesome to be able to show what we've learned so far, and to be able to have an opportunity to do that too. It's great. So we'll get right into it. It's going to be like a, kind of a chronological process of how we went through our project here. Everybody here this year, I'm Chris Frutchson. That's Lucas Trahan. There's Paul DeVoe, Nicholas Hoods, and I'm sure y'all probably already did. In case you don't, some people are, parents and family members and stuff. All right, so we'll start into week 1 of our whole process here. This was say that? Yeah, let's dim the lights. Dramatic effect. Too much. All right, we go. So we're getting into week 1. This is actually a sketch that we drew on the board in the first week when we were first starting out here, coming up with our ideas. So the first thing we had to do was come up with a project, and I watched this video with Nick. Actually, this is a Japanese robot band, and I was like, "This is it. We have to do this. This is so cool. We got to build a robot guitar." So that's how we came up with the idea. The second thing that we had to do was to pick a song. And we were looking at different chord placements, different string presses on the frets to come up with a song. And this is what we came up with: 3 different chords, G, C, and D. And this is actually another picture we drew on the board when we first started here too. So the song is Semi-Charmed Life by Third Eye Blind. So 90s alternative music song. Then we had to come up with a parts list, and this actually took a while.
Pretty difficult.
The first day.
Lots of errors.
Yeah. It eventually came out with all of this. So it was actually $216 that we had to pay for all of this stuff, and then all of these right here were things that were either supplied by us or the school. Like that 3D printer in the back of the room there, and other tools like the soldering station, things like that. But you can see the students donated a lot of stuff into this, and other than just the regular parts that we came up with. The next thing we had to do was come up with some rough sketches, like where do we start? How are we going to get this to work? How do you make a guitar play itself? And these are all of the creative little ideas that we came up with, the actual sketches. Like this is going to be our housing, and the solenoids are going to fit in the top like this and everything. And, when you're looking at something like this, it's kind of hard to see it actually working until you actually get into it and start building it.
Theory is nice, but implementation is always difficult.
Right. So at the end of every week, I come up with an issue slide. So I'll highlight on some of the issues that we came across in the engineering process of making this robot guitar, the GEETAR. And the GEETAR, I didn't get to explain that to you what it actually stands for. It's Genius, Electronics, Engineering, Technology, 90s Alternative Rock. So, yeah.
The 90s is silent.
All right, so our first issue was figuring out how to program the Dragon board. I'll let y'all step into that one.
We had a lot of help from Dr. Block. I didn't really know where to begin. I knew we were going to use C programming, but ultimately we went through a software called Terraterm to load it. And we used Notepad++. Dr. Block helped us set that up to compile a C program into an S19 and load that to the Dragon. I've never dealt with S19 or any of that, so Dr.
Speaking
Block,
Greek language.
yeah, literally, it really helps out.
And the second issue that we came across, we did a little bit of testing, and these are the original servo motors. It's a little tiny motor, little 5-volt tiny motor that we used. The original ones are these cheap little SG90 Tower Pro servos, and they were really slow. And we were like, how's this thing gonna play a song if it just goes like really slow, you know? So we ended up getting some newer, faster servos, bigger, better, high-speed servos right here. These are creme de la creme.
These types are usually used for RC cars.
And they also use them in drones too, for like the propellers. So good upgrade
A
there.
lot faster.
Yeah. And the third issue that we came up across was these were the original solenoids that we had ordered. And for our original design that we were envisioning in our heads, these were way too big for what we were going to design to do, because we wanted to have one solenoid over every single note in those chords that we wanted to play. And there's just no way to fit all of those together on top of like one little tiny fret like that. So that was the third issue that we came across in week 1. Now, what is that?
Right click.
Don't do that. Again. Okay, now we get into week 2. This is actually a picture of my
So
dog,
episode.
Salona. He helped us, he's saying, when are these guys going to sleep? It's 2:45 a.m. because we were up late every night.
Yeah, running on 2 hours of sleep every day.
He's our morale booster. Anyways, so in week 2, the next thing we did was test our components. And here's actually a picture of Paul here, testing out one of our little servos. And Nick's over there making measurements with his calipers. And it's a little sample of what we did there. So the next step was to create our strumming parts, which we created all of our parts. They're all original, just out the top of our head, and using the CAD software, computer-aided design program called Creo, and which is what we used in our class here. Actually, Mr. Bay taught us that. Taught us how to create 3D parts. So the first part that we made was the strumming bass, and this is the original strumming bass that we had made. It's pretty basic, looks
Pretty
nothing
basic.
like
Major
this
flaw.
big blocky one that we got now. But that was the first one that we had made.
This one was also a failure because it had a major flaw. I don't know if it's apparent to either of you, but because of this being here, we would actually have to remove the strings and restring it. There'd be no way to put it underneath the strings to attach it to the same mounting method that we were going to use. So either cut it or just reprint it and draw it. So.
Then we came across and revised it. Now you can see there's a gap there, so we can put it on without taking all the strings off. So it's a strumming bass version 2. Then we made the wrist mount servo, which is one of the very few parts that we didn't have to reprint and recreate over again. So this one came out perfectly, and then you made that one. And then I'll let you speak about this.
So here is a very fun and terrifying night. If you don't know, this guitar is actually my first guitar that my stepdad bought for me, I think 12 years ago. Been playing ever since, and it means a lot more to me than the $75 that it's worth on eBay. So we were having so much difficulty finding placement for the strings to make a drawing so I could actually do placements for my model. It would always be off. So we were doing things down to the thousandths of an inch. It's that accurate we needed to be. So I had, whether or not it was me being sleep deprived, I had the great idea to cover up my guitar with computer paper and painter's tape and slide paper underneath the strings, so I could then take a spray can and actually spray paint over the strings while the paper's underneath it to give us this nice little artwork, so we can get almost or dead on exact dimensions for the strings, so we can have the exact angles. Because if you don't know, guitar neck actually starts at the very tip of the neck. It's a smaller dimension than it is at the base. It comes down and tapers, and it also has a tapering semi cone coming down on the back, which is that curve on the back, so your hand is right around the neck. So it was a smashing success. It was a little, as you can see Corona telling me, you guys really want to do this? And I'm even there, sleep deprived, looking at the camera, was like, am I really about to do this? But we did it, and we got some artwork. You guys can come up and see the actual paper. We're probably going to frame this eventually. Engineering artwork, I guess it counts.
The next task that we had was to create a programming outline. So how are we going to program this? And I'll let you step in.
I started with beats per second. I saw about 102 beats per second. And then I just divided it down from there, how long each note is held. And then we needed to know the angle at which the servo, the elbow servo will wipe the total angle distance. And then we needed to know placement of the solenoids. And I had, in my outline, I had all that written out. How long you're going to hold down the G chord, and how long you're going to pause for in between each notes.
Yeah, and this is the actual original drawing you came up with on the whiteboard. And the next step. Yeah, you wanna speak on this one too? Go ahead.
Yeah, this was our original design, to have we had smaller solenoids that we purchased after we had already gotten the large solenoids. We had gotten those in the mail, and we had noticed how just gigantic those things are compared to these little guys. So we found smaller solenoids that fit the requirement for our design, and we wanted to have the chords played individually by each solenoid. One solenoid per fret per note on each string. For the chord, just for the chords, we're going to use eight solenoids, and so it was a great idea. It's going to work if we had more powerful solenoids. We'll get to that later on. But the main issue with my first print of this was that I actually mirrored the placement of the solenoids on my part because of the way the plane that I was viewing inside the Creo software. And when we printed it out, went to go mount it and find that none of the holes matched up on any of the chords that we wanted. We knew an issue would happen. So yeah, I believe the next part is
Yeah.
the next one.
Oh, no.
Oh, I'll let you continue.
Okay, we'll get to that at the end. So the next part that we had to draw was the arm mount. This is the first version of our arm mount, which replaced this one. So you can see the difference. This one is a lot bulkier, and it catches on the sides of things a lot more, less range of motion. So we got this one. That was the first version. Right? And then the second one we did is, it looks like a propeller. This is our pick mount, and it actually held two picks on each side. And our first design for the picking was to have two picks, and it would just rotate a little bit this way, strum, rotate a little bit this way, strum. And later on we found out it would be more efficient to just do it with one pick, and you wouldn't have to move your strumming as far to compensate for 2 picks on each side. So this was the first pick mount. So we'll get into the issues for the second week, which we already mentioned half of them, but we'll still rehash them this year. We had the strumming bass, of course, and another thing he didn't mention about the strumming bass was that here I had made this with exact dimensions, and when you create a part on a 3D printer with exact dimensions, the filament that comes out will expand, and if you see here, this thing, it'll go in just so far, but it won't go in all the way. See, it's too tight because of thermal expansion on here. The filament expanded. So we learned our lesson there. Not to, you gotta add a little bit a giveaway, you know, for expansion whenever you're printing your parts there. So that was a good learning mistake that we had made there. And you can see the second one that fits in perfectly. Look at that. So it's better. And then, you know, of course we improved the bar going across so we could put it on without taking all the strings off.
Yeah, make it look fancy.
Oh yeah, we added some nice curves to this side. It's prettier. It's prettier, yeah. More features there. The second one he had mentioned earlier is the mirrored solenoid housing. And also it had the same expansion error with this one. See, the solenoid doesn't fit into the holes because it is made with exact dimensions. So there's another learning mistake we had made there. Of course, he talked about the string dimensions and how he had to spray the strings to be able to get it to measure.
The spray paint actually wiped off with just water,
Yeah, that was.
so you didn't have to string the strings.
And
If anyone was wondering.
And then the last mistake issue that we had for that week was actually in our design, and I'll let y'all talk about that one with the 4 relays to the 8 solenoid design.
The problem with the 4 relays, 8 solenoids is that they back feed. So when you try to turn one off, when you pick up the other solenoid or the other relay, it would back feed, energize.
You want to explain what backbeat is?
It would send the power back into it.
We originally decided, the original thought was to have one relay for each chord. So chord G is going to press down on, let's say, these 3 strings, and then for the next chord, you might also press down on string 1, but it's going to use a different relay. So if you have relay 1 energizing these strings, and then relay 2 tries to come back and energize the same string, everything that's attached on that string is going to see power from relay 2. It's going to backfeed in the first set of solenoids that we don't want.
Yeah. So that was a major flaw that we had there, and good thing notice it before we actually built it.
And also we had the solenoids, we were trying to drive it from just the dragging board, which is this board up here, and it didn't have enough power, so we actually had to mount these auxiliary relays and drive them from the dragging board to supply enough power to energize the relays. We had solenoids.
And the original relays that we had ordered, their running capacitance was too high. It would draw too much current to run it off of our controller board. So we had to order those relay cards right here. Right? That was another one. I didn't put that up here. Alright, now we're getting into week 3. Of course it didn't look that good, but I look at a picture. So the first thing that we had to do is rebake the fretting mounting housing right here, and so that the solenoids can actually fit into it.
As well as fix the mirroring issue.
Yeah, if you see where he's talking about mirroring, if you look at the hole placements for these, they look different, right? Like this one's an upside down version of the bottom side of that one. So it was kind of an optical illusion when we were drawing it in the program. And, yeah, had to account for that. And then we upgraded it again after that because the way we were planning on mounting it, it would have been sitting flat on the strings, and we're like, wait, it needs to be held up
Well, that
off of
was
strings.
that was because of the first bottom mount. These bottom mounts actually attached to the lip of the guitar, and then we had planned to have screws go in this way, two screws, and then also one coming down, so that these would be screwed together, as well as screws screwing into the top, and that would add the height. So I actually ended up dropping this bottom mount design for another one, which we'll see soon, and that allowed us to do that. So you'll see my redesign of the third version of this soon.
Yeah, this is the third housing.
That's why we had the standoffs on that. The standoffs were actually supposed to be in between each string to add support. Later I found that that was too much support. It didn't need that much surface area to hold it up, and you'll see later on with new designs.
So, when I talk about how we upgraded this one, this is the pick mount that we have now right here. Doesn't look like a propeller anymore on the tip of it there. So, it's our new design.
That was one of the other ones that didn't need to be printed again.
Yeah, after we printed it. This is second version. And then after that we did some more testing, and I'll let y'all talk about that.
These small solenoids, we realized that they're also drawing a lot of current. And Paul actually has a digital thermometer that you touch it a few times and think, man, this thing's getting really hot. Paul pulled out his thermometer and they were getting up to 160 degrees. So we decided to test it some more, ran them for 2 minutes, held down all the way, and then it started almost melting the plastic a little bit. So we had to.
It didn't melt a little bit.
If anyone don't know, 3D printed parts, if they're actually left inside of a hot car, they'll melt and build into like a little mound. Just a hot car is enough to melt it. That's why they're mainly meant for prototyping, not the finished products. But
And the servo actually locked up after that too. I forgot to do that.
it broke itself.
Yeah.
So once we saw the
China
problem
servos
with the
are
heat,
not good. Like China solenoids.
had a problem with the heat with the solenoids, that's when we decided to go with these larger solenoids here and actually do the bar boards instead of the individual notes.
So we'll have it on the issues for the third week here. So the first issue that we came across that hasn't been mentioned already was that the wrist servo, this one right here, this little servo right here that turns the pick going this way. We call it the wrist because it mimics the wrist motion on your hand when it's strumming. It was getting really wobbly.
It would dig into the strings and make very unpleasant sounds.
Because it was a big heavy thing just bouncing on the tip of this other server right here. So it made this clang clang noise when we were trying to strum the strings, and it was terrible. The second issue that we came across was the propeller pick mount, which we upgraded to the one that we got now. And then the solenoids, as we mentioned earlier, got hot and was melting the plastic, and we didn't want this thing to catch on fire when it was playing. And also, the solenoid was too weak to push down on the string to hold a good note. It would distort it a little bit, but it wouldn't push down hard enough for us to get that, good sound whenever we strum over it. So that was a third issue we had for week 3. Then we get into week 4. Oh, you described your baby
was
right there.
the baby, the final design that took literally 5 weeks and 200 hours of printing and drawing and conversing ideas and all of that. So we settled on the big solenoids, made it easier on me for the actual design.
Don't catch on fire.
They're very efficient. They don't get hot at all. We can pretty much use this for about an hour straight before we actually see any temperature rising, which is really nice.
And they have 45 newtons of force.
They're very strong, almost like someone just hitting a wall almost. But this new design kept the same kind of idea for solenoids, but we ended up designing to have a solenoid play a solid chord on every fret. So if anyone isn't really musically inclined, if you heard of OpenG tuning. If you tune a guitar to OpenG tuning, which is, I believe, G, D, G, D, B, D, that actually allows you to play full chords by just holding all 6 strings down on one fret. Basically, like, I didn't hold any chords down, any strings down at all. So it makes it easier to do the chords that we needed, doing it that way, as well as adding on slots for the different little bits and pieces that we made for the standoffs, and then also the little pieces that actually strike the strings on the frets. I later found that, well, actually, let me start a little farther back. This actually needed about 14 and a half hours to print. Really, really long print. And also came out a little warped, just because doing big parts on a bed that can, so we pretty much covered up the whole area for the printable area on the printer. It was just edge to edge, the biggest piece that it could possibly make. So it came out a little warped. Whenever you do make big parts on 3D printers, the ends that are flat and large can warp a little bit. But ended up spending a day or two actually modifying that physically with just a drill, and actually drilling out up and down and across, and also widening certain parts. All edits that I could have done and just reprinted, but we had no time to do another 14-hour print, and also doing our finished job and everything. But as you can see, it's our final product.
The next part that we made was the improved strumming bass. And remember I told you the wrist servo was wobbly? We added an extra extrusion around here to support the servo so I can rest on that, and it has no room to wobble anymore now. So it has no choice but to just go straight left and right now.
It's also pretty.
Yeah, it's prettier too, yeah. A little bit more intricate than this. Well, I'd say, yeah.
Just a little bit, right?
It's the engineering process there. Next, I made the new strum arm now that holds the shaft right here, this little piece. And it's smaller, allows for more range of movement, and it's lighter, and it looks better. So, oh yeah. So we got the fretting top mount version 4 there. This is like a better picture of it after we had originally mounted it. And then we made the controller display board, the shiny light thing you got going right there. It's holding the controller and the relays. Built that. And then we did some testing. We had to test all of our parts and came up with some more issues. We'll get to that later. I don't want to spoil them.
One of our few pictures of Lucas.
And then they did some reprogramming to fine tune up on the programming. Of course, we had kept making modifications to this, so of course you got to make changes in your program to account for that too. So we did that. Then there's Paul doing some wiring and Lucas there. We got him again. And then, so we'll get to the issues of week 4. Of course, I told you about the smaller arm mount. He told you about the bar chords, on how we had redesigned our original design from this little housing into that big heavy metal monster right there. And it's weighs about 9 pounds. It's a bowling ball. It's huge. And the different design on the fretting. See, this is how we designed it to mismatch, to play chords. Now we're doing straight lines, boom, boom, straight down the fret. So that was another one.
Additionally, on the original design, Block had originally backed me on it. This design will work. We just have to create our own solenoids with our own force, so that it's tailored to our actual approach for our design. It would work. It's just it wouldn't work for a 5-week project.
These are weak, cheap solenoids. Of course, we had a limited budget, a limited time frame, so I think we did pretty good. The next issue was the spacers and the fret bars, which were the most frustrating piece of this entire project, I think.
Probably took the most
You
time.
go ahead and tell them about that too.
The most issues, just so many problems. There are just lots of issues with, since I had to modify my top mount by hand with a drill, lots of dimensions were off, so I ended up having to do individual drawings for every single little piece, and they're all ever so slightly different. You probably won't notice, but they're different, I can tell you they are, and they make all the difference of being able to have this project now and not having it at all, or anything to show you. But these guys actually just are actually right underneath. When you come up after the presentation, you can come and view it, and you'll see that these feet are under there. They're a different color now. They're actually black. We used a different filament because we were short of time, so we had to use that 3D printer instead of mine at Hutch's house in the project room. The placement of these feet in between the strings were crucial because if it strums, the strings can ring against the side and make an unpleasant sound, which we don't want. We want it to be as clean as possible for what we're trying to do, as well as keeping the height correct. Since everything is, all the strings are gradually getting a larger angle as they go down the neck, it just makes it so hard to do placement and keep a point where there's reference to actually do these drawings. So there was a lot of reprinting. I think I probably did 8 different designs for these little tiny feet, probably like 8 hours or 10 hours of printing and drawing. It's really difficult, but we ended up actually finishing just on time, probably yesterday. So it's a miracle, so thank you for coming.
Alright, so this is the last part, the beautification of our project in week 5, the last final stretch. So, first we sanded all the parts and stained them.
If you guys didn't know, you can actually get wooden filament. The stuff that you actually make 3D printed parts is called filament, and you can get different types of filament, PLA or ABS being acronyms for different types of material. You can get PLA wood filament that is 40% bamboo fibers, which once it's printed into a part and you do the right percentage of infill, which is the amount of filament that it is. 3D parts aren't actually 100% plastic. There are pockets, and they make little patterns to make it make a structure, like that. And afterwards, you can sand it down, and then you can actually stain it. As long as you actually have to stain the wood grain. I've had experience doing wooden stain on 3D printed parts, wooden filament parts, so I've been pretty good at making those wood grains show up just by making darker lines as I do the coats. And I think it turned out pretty well.
Yeah. Then we polyurethane it in the dark with the lantern because it was like 1 in the morning. Like,
I think
we had a lot of late nights on
I think
this.
I left your house at 2:30 that night.
Yeah. And then we made the PowerPoint that you're watching right now. And somehow it came into Inception. I don't know how we got this picture inside of a picture. I don't know what that should be.
It was late, and we don't know.
We're all doing it.
Just take our word for it. Oh, and my favorite part, and probably the only part that printed well.
Yeah, we didn't have to reprint this one. I can't believe it. That was our final part. So the issues for this last week, were the spacers and the fret bars again. And the wobbly servo again. We ended up taking super glue and cranking it in there, and then tighten that bucket down. It ain't going nowhere now. So no more wobbly, no matter what. And now, the moment you've all been waiting for. Dun, dun, dun.
If you guys like to come up and view it,
You want to play it first
Oh yeah, let's play it.
for the recording?
Is it?
Oh, it's on manual right here.
Yeah.
Let me do
Yeah.
the sound check.
You gonna play this? You gonna play the song?
Yeah, do the manual one first. Explain it.
All right, started.
Yes. so
Start the song.
wait. Yes. All right, so you want to explain the programming now, or? No, we good?
Start the
All
song.
right, well, let's have it play a song here. Load up the song.
That was manual mode. We were controlling that.
If y'all ever heard that Third Eye Blind song? Don't judge. We have 5 weeks.
We had to completely change our design, so yeah, we couldn't exactly change the PowerPoint. And there we go.
Gotta get it. It's a long song. We don't make it.
Awesome. Thank you.
Thank you guys for coming too. That was fun.
Let me just add before everybody gets up there and takes a look at it, and you guys can show them all the details and stuff. They talked a lot about all the parts and everything that they did. Lucas and Paul also did a lot of work on the side. Every time they printed a part, Lucas and Paul would be, putting it, wiring it up, checking it, and saying, nope, ain't gonna work, or it's too hot, or whatever it is. Lucas did a lot of with the programming, changing it and getting it tuned up, and Paul did a lot of the wiring, made it even look nice. Harness standards and stuff like that. So
She wires helicopters.
they work
so-
very well together as a group. Time management, planning out what they're going to do, and tackling the jobs. And like I said, beginning, I thought, no way were they going to get it done, and I thought they did a great job. So give them another hand, and you guys can.